graphing linear inequalities in two variables. So the first thing is to review inequality symbols and using the form of linear inequality. Now the first symbol is our greater than symbol. Oops, let's get back to that page there. Okay, greater than symbol looks like that. And if I want to make that into a linear inequality, if you remember, a linear equation is y equals mx plus b. So when I'm dealing with an inequality, really I'm just replacing that that equal sign with an inequality symbol. So I'd have y is greater than, and let's just use x plus 6. If I had greater than or equal to, well, that'd be that symbol pointing to the right. Looks like that with a little line under that. That line under it means the equal to piece. So y is greater than or equal to x plus 6. If I had less than, it would point to the left. Let's just use the same. Y is less than x plus 6. And less than or equal to would have the little line under it still pointing to the left there. Y is less than or equal to x plus 6. One other thing to note about this is if you're actually graphing these, a greater than and a less than, the ones without the lines under it are dashed lines when you're graphing them, meaning points that lie on those lines are not solutions to your inequality. They will not satisfy your inequality. Whereas if you have the equal to piece, that little equal to chunk right down there, and there, that actually tells you that it is a solid line, and any points on that solid line would be solutions. They would satisfy, the coordinates on that line would satisfy the inequality. Okay, well, let's go ahead and take a look at how we can check solutions here. So if I had an inequality 4x plus 2y is less than 8, and I'm trying to figure out if an ordered pair, the ordered pair 1, 2 is a solution to that, really what that means is I am checking that coordinate or that ordered pair by substituting the x value in for x in your inequality and the y value in for y in your inequality. So this would look something like 4 times x would become 1 plus 2 times, well, y becomes 2 is less than 8. And you're trying to see if it's a true statement. Is 4 times 1, which is 4, plus 2 times 2, which is 4, is 4 plus 4 less than 8, or is 8 less than 8? Well, no, it isn't. That's a false statement, which means that the ordered pair 1, 2 is not a solution because we get a false statement. Let's try another one. If x is 3 and y is negative 6, and you have 3 times x, which is, well, in this case we're saying x is 3, so x is 3, minus y, which isn't y anymore. Let's put some parentheses there. Okay, y is actually negative 6. Is that greater than or equal to 14? Well, 3 times 3 is 9. And notice I wrote it out. That shows me that double negative there. 2 negatives make a positive, so that's plus 6. Is that greater than or equal to 14? Well, that's 15. 15 is greater than 14. So the ordered pair 3, negative 6 is a solution because it makes the inequality true when you substitute it back in. That's a way to test those or check them. We're going to try to graph some of these, and the first thing we're going to do is graph using one variable. Okay, so x is greater than negative 3. Well, first thing to note, notice this is greater than, okay, and it says x. That means x is greater than, I'm going to find negative 3, which is right here on the x-axis. It won't cross the y-axis because we don't see a y in that equation. X is always going to be at negative 3. And notice this is it's a dashed line running like this. Okay, it's a dashed line. All right. Whereas this one has the equal to chunk under it. This is going to be a solid line. It's going to cross the y-axis at negative 2. There's no x, so it only crosses at negative 2. All right. So we know that our solutions for x is greater than negative 3 cannot be on the line because it's dashed. So, like, for instance, if I substituted in this coordinate right here, negative 3 is not bigger than negative 3. It doesn't work. What I need to find out is which side are my answers on. Are they on the right-hand side or the left-hand side of that line? I think the book calls that a half plane. Which half plane is it on? Well, what I like to do is I like to test this coordinate right here. And I like to test that one because it's the easiest one. It is the coordinate 0, 0. So what I do is I say, well, if x is 0, if x is 0 and y is 0, I substitute those back in just like we did on the previous problems. Substitute 0 in for x. There's nowhere to put a y here. So is 0 greater than -3? And the answer is, yeah, it is. That's a true statement. Which means this is a solution. 0, 0 is a solution, which means I am shading on this side of the line. That means all of my solutions fall on the right-hand side of this line. Which also means the solutions on the left are not true. So for instance, -5, 0. -5 is not greater than -3, so it doesn't work. Okay? So I could do the same thing here. I could test 0, 0. Notice it's just y though. When y is 0, y is less than or equal to -2. Is that true? Well, so is 0 less than or equal to -2? No, it's not. That's false. Meaning 0, 0, this point is not a solution, meaning everything on the other side of the line is a solution. Okay? So for instance, right here, -4 is a solution. Okay, because -4 is less than -2. -2 is a solution. That's why it was a solid line, because -2 is equal to -2, and we have that equal to piece. So that's how to graph them when you have one variable. Remember, if it just says x, it's only going to cross the x-axis. It just says y, it's only going to cross the y-axis, your line is. Wherein, if you have an x and a y, like we have on these problems, then it's going to cross both axes. So in this case, I'm going to go ahead and look at it. Well, I first noticed, well, it has the equal to piece, so this is a solid line. And this solid line has a positive slope to it, so it's going to do something like this. It's going to rise from left to right. This, if I look at this one, well, this is a dashed line, but it's still a positive slope, so it's going to rise from left to right. It's going to look something like that. And if I graph them, remember, graphing linear equations, y equals mx plus b, well, it's the same thing. It just has an inequality. Remember, this is your y-intercept right here. And this is your rise, the top, and the bottom part of your fraction attached to x is your run. So we're going to start at -4 on the y-axis. We're going to rise 4, 1, 2, 3, 4. We're going to run 3, and there we've got it. We're going to have a solid line that goes through those 2 points. All right, and then I need to test the ordered pair 0, 0. Well, when I substitute 0 in for y and 0 in for x, notice something cool happens when you use 0, 0. That fraction is eliminated because a fraction times 0 or anything times 0 is 0. So you have 0 is less than or equal to 0 minus 4, or 0 is less than or equal to -4. That is false. 0 is not less than -4. Oops, I've got to spell false right. Which means I would have to shade away from 0 or below, some would say below this line. Anything on the line or below it is a solution. Now over on this one, y-intercept -5. Notice I rise 2 and I run 1, right? The denominator is 1, so up 2 over 1. It's a dashed line. And I'm going to test 0, 0 again. 0 is greater than 2 times 0 minus 5, or 0 is greater than -5. This part becomes 0. 0 is greater than -5. This is true, meaning I shade over that point, meaning anything that is above this line is a solution, or it cannot be on the line because the line is dashed. Points on that line will not satisfy it. And you can test those points. You could test this point. It would not work. Okay, any of the points on that line would not satisfy your inequality. Okay, well, let's go ahead and try another one here. Okay, notice these are not in slope-intercept form when we're graphing them. So the first thing to do is to get them slope-intercept form. I do know it's a dashed line, though. I don't know the slope yet, so I can't tell you which way it's going. But I'm going to go ahead and figure that out, though, by getting y by itself. I'm going to subtract 3x on both sides. Okay, so I get negative 2y is less than negative 3x plus 10. I'm going to divide by negative 2. Now, if you recall, when you divide by a negative and you're dealing with inequality symbols, what happens is that inequality symbol switches directions or flips over. Okay, so let's go back to that real quick. When multiplying or dividing by a negative, flip the sign. Okay, so that flips over, and negative divided by negative is positive, so we get 3 halves x. Positive divided by negative is negative, negative 5. So we have a y-intercept of negative 5. This line is positive slope and it's dashed. It's going to look something like that. We're going to rise 3, 1, 2, 3, run 2. Rise 3, run 2. Okay, and it is dashed. There we got it. Now if we test 0, 0 out, it's right there. I could test it in the first inequality or the second one. I'm going to go ahead and test it in the top one. Okay, so we'll test it in a different color here so not to get it confused here. We'll go 3 times 0 minus 2 times 0. Is that less than 10? Well, notice that's 0 and that's 0. So is 0 less than 10? Yes, it is. That is true. So we shade over that point. So everything above that line is a solution. There you got it. Okay. Let's go ahead and try one more. All right. Notice on this one, there's 2 different ways I can do it. I could change it to slope-intercept form, or I could just use intercepts, x, y intercepts. Remember, intercepts just say, well, the x-intercept is when y is 0. So if I make y 0, x has to be 2. So the x-intercept is 2, 0. The y-intercept is when x is 0. So if I make x 0, well, y would have to be negative 2. We have to bring that negative over. There's my intercepts. There's 2 points. 2 points can make a line. In fact, I can figure my slope. If I rise 2, I run 2. So I rise 1, I run 1. The line would look something like that. And it's a solid line. Now, for those of you like, I have no idea what he just did, well, then just do it the way we did the previous problem. Subtract x first. Get y by itself. So you get negative y is greater than or equal to negative x plus 2. This is a negative 1y, so we'd have to divide by negative 1 next. Remember, dividing by a negative flips that sign. So that gives me x. Negative divided by negative is positive x, and positive divided by negative is negative. And notice my y-intercept's negative 2. I have a slope of 1. We rise 1, run 1. There we got it. If I test 0, 0, I'm going to substitute 0 in for x. I'm going to substitute 0 in for y. And that says 0 is greater than or equal to 2. That is false. And let's spell false right. Okay, which means I would have to actually, I couldn't shade over that. I'd have to shade below this down here. So anything on the line or below it is a solution to the inequality. So you pick any point that's in that shaded area or on that line. All right, I think that's all I've got. Yep. All right, good lucky.